Welcome to the online version of the Biological Nitrogen Fixation and Nodulation Practical for the AGRI2001 course at the University of Sydney. Legumes are plants that we use fairly heavily in agricultural production for a number of reasons that you will have learned about during this unit of study. The legumes have a symbiotic relationship with a group of bacteria called rhizobia. The legumes will form nodules to house the rhizobia in the root system, and in return the rhizobia will provide nitrogen in the form of ammonia that they've fixed from atmospheric nitrogen. Now the process of nodulation doesn't just happen by chance, or doesn't just naturally occur all the time, and so we usually intervene by providing rhizobia of the right strain for the right type of crop. Now the interaction also involves nitrogen that's already in the soil, or nitrogen that's supplied in the soil, and so plants, the legumes, may take up nitrogen that's available in the soil in preference for nodulation. And so we might find poor nodulation where we have a large amount of nitrogen in the soil or provide it as fertilizer. So the whole process is an interaction between the soil, nitrogen in the soil, the strains of rhizobia, the amount of rhizobia, the types of legumes. We want to explore this a little bit in this practical for you. Ideally, you'd be hands-on in this practical, but we can't do that at the moment. So what we've set up is field trials and pot trials based on exploring this interaction of nitrogen with rhizobia and inoculation. So we've got treatments where we've got a control with no nitrogen and no rhizobia addition. We've got treatments where we've added nitrogen and no rhizobia. A treatment where we have no nitrogen and rhizobia. And we've got a treatment where we've got nitrogen and rhizobia added. We've done this both in the field and in pots. The reason why we've done that is we've grown these winter crops first semester here in Australia out of season. And so the production capacity in the field is very, very dependent on the climate, things that go on. And so we want to have a backup. Plus it gives us a chance to look at different things. So I hope you enjoy this practical. You're going to see the results of the treatments through this video, a number of processes that go on in the practical you'll get to witness, unfortunately without hands-on. Then at the end, the culmination will be at the end of this video, the data that's been collected by us during this process. You go through that with Ros Decker, our expert on nitrogen fixation, and she'll also talk to you about methods that we have of measuring the success of nodulation on the plants and ways of quantifying the process of nodulation and how well it's gone. So I hope you enjoy this practical. I'm on my way out to John Pye Farm to get those plants for you from the field. Bye.
I'm here at John Bruce Pye Farm, owned by the University of Sydney. In front of me is a crop of faba beans grown out of season as part of the AGRI2001 course. What we're trying to do here is run a couple of treatments of addition of nitrogen and the addition of rhizobia to see the impact on both the crop growth and to see the impact on the nodulation. So just looking at the growth here today, in front of me I've now got the control. 4 rows of no nitrogen and no rhizobia. And if I look down the rows there, the crop is slightly variable in height. The canopy is a little less dense than the treatment next to it, which is no nitrogen plus rhizobia. Down the rows there, fairly uniform height, good density of production. These plants are just coming into flowering, so they're quite young still. So we've got a visual difference between the control and the treatment with just rhizobia added. As we move down the plots, might be easier to actually see the difference at the bottom end here of the far rows here are no nitrogen and no rhizobia, smaller less dense plants compared to the treatment with rhizobia. So as I say, we're getting a difference there in the above ground biomass with the addition of rhizobia. The treatment in front of me now is the addition of nitrogen. So no rhizobia, just the addition of nitrogen. And again, we have a reasonably even looking crop with a reasonable density of production. Potentially slightly thinner than with the addition of rhizobia. Treatment number 2. Still, it's far better than the control. The final treatment we have here is addition of nitrogen and rhizobia, and again we've got a reasonable production growing here of plant biomass. So I guess in summary, the treatments with the addition of nitrogen and the addition of rhizobia are probably above ground biomass looking relatively similar. All 3 of them are better than the control with no nitrogen or no rhizobia. So what's of interest to us now as well is how well the plants have nodulated. What's the difference in the nodulation process here, which will tell us about the resident rhizobia and their ability to colonize these plants. Remembering these plants are still quite young, as I said, some of them are only just coming into flowering, so we are growing things out of season. So we'll go and explore the nodulation of these plants in the practical.
Plus N.
So we're in the lab now, and we're going to undertake the practical work of exploring the impact of nitrogen application and rhizobia application. We've got Adriana and Iona who are helping us out tremendously to set the whole prec up.
Hi.
Thanks, ladies.
Here's some chickpeas with a plus nitrogen treatment. Adriana's going to show you faba beans.
It's faba bean
Faba
minus N plus R. So if you guys were here, you would have done all of this by yourself.
Thanks very much.
Thank you.
Beautiful.
This is a faba with plus nitrogen plus rhizobium treatment. We are going to gently take it out of its pot. Then we are gently going to release the roots. As you can see, there's a big nodule there at the moment. You can see one. Hopefully there will be more. Now, I'm just going to give this a bit of a wash to see what else we can see. Oh, seeing that? There's some more nodules there. Be enough to see. So.
Very good, Iona. Thanks for preparing samples for us.
No problem.
That was a bit of a wobbly end. Okay, here we are now with the results from the field trials with the faba beans, this year faba. We've got 4 treatments there, minus N, no nitrogen, plus N, nitrogen added, plus N plus R, nitrogen plus rhizobium, and minus nitrogen plus R, no nitrogen plus rhizobium. And just looking visually there, you can see that as we go from 0 nitrogen to plus nitrogen, the bulk of the plant is increasing. The root density maybe is a little more dense, but it's certainly there's more bulk on the plant. The next treatment is nitrogen plus rhizobium, and again we've got a bit more of a kick in bulk production. The plant is a little taller, maybe not denser, but a little taller. And then the final treatment, minus nitrogen plus rhizobium, we seem to have a drop back in production again. So the nitrogen here in this experiment on these plants, where they were grown at this season, has certainly given a production boost by the look of it here. Now if we look deeper into the impact of the rhizobia, we should be able to see in the nitrogen trials, if I zoom in on this plant here, we've got no nodules, no nitrogen, but also there's 0 nodules, which means that there's no natural rhizobia in the soil that can form a symbiosis with the faba beans here. So no nodules. As we move along to the plus nitrogen trial, again, no nodules on the roots there. If we move over to the trial with the nitrogen plus rhizobium here, we start to see rhizobium. So there's a symbiosis being formed. So the addition of the rhizobium, the addition of the rhizobium has given us nodulation on this plant, and even with nitrogen applied as the treatment, good nodulation there. And if we move across to the minus nitrogen plus rhizobium treatment, we've got even more rhizobium forming nodules, a symbiosis here. So a bigger treatment effect when there is no nitrogen in the soil. So in effect, we've got, using these faba beans in the soil out at John Pye, we've got a production benefit from adding nitrogen here, and we've certainly got an increase in rhizobia, increase in nodulation with the increase in rhizobia. We also had some chickpea growing out there at John Pye, Sisa arietinum, and as you can see we've got the same treatments, minus N plus N plus N plus R minus N plus R. And if you look across the whole range of treatments there, you can see there's a big kick, it would appear, from adding nitrogen to the plants there. From the minus N to the plus N we get a kick, and then as we move further along, the plus N plus R to the minus N plus R, there seems to be fairly similar production, as you can see there. So not a lot of difference. So the addition of nitrogen or the addition of the rhizobia seems to have given a kick, maybe a fairly similar kick compared to no nitrogen. So if we now go down and have a look at the impact on the root systems, the two nitrogen systems, minus N, we've got no nodulation from those plants. If we move across to the plus N treatment, we've got a slightly bigger root system, but again, there's no nodulation going on there. If we move now across to the plus N plus R, again we've got a bit of bigger root system potentially, but as we zoom in a little closer you can see rhizobia will form a symbiosis plant, and we've got some nodulation happening. Over to the minus N plus R, no nitrogen plus rhizobium, we've got what it would appear to be more extensive nodulation going on. No nitrogen, we've got a better nodulation process occurring here. So, as with the faba beans, we've got certainly a response to the adding rhizobium to these chickpea plants. So again, soilies were grown side by side with the faba beans. The field has obviously no rhizobium that would happily form a symbiosis with the chickpeas here. And we've also got a response to nitrogen, maybe not as big certainly as we saw in the faba bean. Adriana and Iona and the team also prepared some plants for us in the glasshouse in case we had some trouble out at John Pye. And here we've got the chickpea that have come out of the glasshouse. You can see we've got the same treatments as we had in the field, minus N plus N, plus N plus R, minus N plus R. And we can see here again, I think you should be able to see, that by the addition of nitrogen, as we move from the left to the right, the addition of nitrogen itself has produced a more bulk on the plant, and it's a greener plant, as you can see there. So there's been a production increase. As we move further across, the plus N plus R, again fairly similar production to the plus N, and then the final treatment, minus N plus R, has dropped back off again. So again, we've got a bit of a nitrogen response going on here in terms of the above ground production. Let's see what we've got in terms of nodulation. So, as we expect, as we'd hope to expect, the minus nitrogen treatment, there's no nodulation. No nodulation at all. As we move across to the plus N treatment, again, there's no nodulation going on. So again, this is in potting mix, so we don't expect there to be rhizobia in the potting mix, so we're getting the results we would expect there. As we move across now to the nitrogen plus nitrogen plus rhizobia treatment, I'll just zoom in here. We've got a more extensive root system here. Whether we can attribute that to the rhizobium is another thing, but as you can see here, again, as I zoom in here, we've got a plus nitrogen, but we've got also no rhizobia. No rhizobia being produced. No rhizobia symbiosis with the plant to produce nodules when there's nitrogen involved in this potting mix in the glasshouse. And as we move across now to the minus nitrogen plus rhizobia, you see we've got the reverse. We've got, as we're expecting here, a big response, extensive nodulation on the root system here. We've got quite an extensive root system here, and so where we've got no nitrogen in the system, no nitrogen in the potting mix, the plant and the rhizobia are responding to form nodulation in this symbiosis. So here's the results of the pot trials, again with the same treatments, with faba bean. As again we go from left to right, no nitrogen, we add nitrogen, and then we're adding rhizobia, taking away nitrogen at the end. And you can see, similar to what we saw in the field actually, that adding nitrogen, while it hasn't given us a potentially taller plant, there's a more bulkier and it's a greener plant. So if we zoom in, we'll move over here anyway, there's a marked difference in the colour of the plant. So while the plant is, the less nitrogen plant has actually produced a reasonable amount of biomass, it's looking quite green, and what you actually notice as well is that it's actually started to flower, so it's under a bit of stress here, so it's moving much further through the growth stages without the nitrogen than the plus nitrogen plant is. And then as we move down to the plus nitrogen plus rhizobia, you can see that we've got a bigger plant. So there is some added benefit of having both things working there. Hopefully if we can see whether there's rhizobia there or not, we'll have to have a quick look. And then we've lost a bit of bulk here where we've taken the nitrogen away from the system on the furthest right. So if we move back up here to the no rhizobium treatment, and we have a zoom in onto the minus nitrogen treatment, and we can see again, as we saw in the field, no rhizobium, addition of no rhizobium, we get no nodulation. We move over to the plus nitrogen treatment. We've got a bigger density of roots here with added nitrogen, but again, no nodulation, no nodules inside here. Okay, let's see what's happening. Well, we've added rhizobia, but we've also got nitrogen. Again, good root system. As we go in deeper, we can see we've added rhizobia, and we've got nitrogen and rhizobia here, and we've got nodulation occurring here, as you can see, around the root system, from the crown and around the root system and out. So the symbiosis has worked there. And over here, where we've got no nitrogen and rhizobia, we've certainly got nodulation going on. It's not as distributed throughout the roots, and Ros might help us with a bit more information about that, but if I can get in here a bit tighter with this camera, these are extensive crown nodules. The largest we've probably seen here, or groups of them, if you like, are large nodules on the crown of that plant. So the lack of nitrogen has certainly helped the plant nodulate. So again, we see a very similar result to the field plants. So now we've observed those plants, I've got two of the treatments here from the field trial of the faba beans. I've got the no nitrogen on the left and the plus nitrogen on the right. What we need to do is we're going to make an estimate of how much nitrogen's inside these plants from the different treatments, and so to do that we're going to separate the above ground biomass using a scalpel from the roots, just like that. Then I'm going to take the plants across to the scale and weigh them. A fascinating part of the afternoon which I'm sure you would have all appreciated. We'll tear the scale. Prepare the sample to fit on the scale. On the scale we go. So 0 nitrogen, 41.65. Right, so we've severed the tops from the root system and we've gone off to weigh them, and now we're going to have exploration of the roots here. As you can see, we've got a reasonable array of nodules here on this root system. And as you would have heard from Ros, she'll be talking to you about what goes on in those nodules and how to identify good active nodulation. And I've taken a scalpel to this one here, this bunch of nodules here, and I'm just going to cut it, flick it open. If we just look inside there, we should be able to see the leg hemoglobin, the strong red cover like the hemoglobin in our blood, the leg hemoglobin that tells us that these are active nodules working hard at doing their job, supporting the plant.